Okay, Physics 1, let's go to Assignment 3, Vector section. Assignment 3. Okay, read problem 1, and I want you to sketch the vector. Make the best sketch you can of the vector. You'll choose some random length, but try and get the degree right. And then write as dotted lines the components of that vector, and then we'll solve the problem. So I think drawing good sketches is essential, and I really encourage you to always draw sketches of the problems to try and get a sense of what you're going to find. Now, I should have labeled the angle 58.3 degrees, but I drew it so that it was more than 45 degrees. Now that I look at it, it's probably not steep enough. But what you should, if you're thinking ahead, this angle means the x component is going to be smaller than the y component, right? Because it's bigger than 45 degrees. In my sketch, I can see now my angle's not steep enough. And we're asked to find what is the north, south, or y component. So we're going to find this. And so go ahead and do that, and then see if you get the right answer. Just use my numbers. Okay, I hope you're not, don't be lazy, do these out. Don't just watch me. It's much more beneficial if you do it. So, first of all, I labeled everything, which I should have done, 58.3 degrees. Notice, v is a vector. This is the magnitude of the vector. That's the notation, equals 15.4 meters per second. We show the vx and vy, the components of the vector v, and the north-south or y component is vy, and the equation is vy equals v sine theta. That's from the equation sheet, but you don't need the equation sheet, right? Because you can see vy is opposite and v is the hypotenuse, so that would be the sine function. So I write the equation down. Notice the formatting, and you should do this. Write things out. So vy equals v sine theta. Then I write down what it is. Vy, there's v, there's the sine of theta. It's a little messy, crowded. And then I do the calculation. Notice I put the units in, and I get vy equals 13. I run out all those digits in case I need them for a later calculation. But when I report the answer, since the data is 3 significant figures, my answer has to be 3 significant figures, and so the y component is 13.1 meters per second. And then we have, I don't know if you've been introduced to this yet, but I'll introduce you now if you haven't. We have this IJK notation. So let me pause and just tell you about that. So in science and engineering, since vector components are so important, we have a notation for indicating them, and it's called IJK notation. And I hat is a vector of length 1 along the x-axis, and j hat is a vector of length 1 called a unit vector along the y-axis, and k hat is a vector of 1 along the z-axis. And why don't we call it x hat, y hat, z hat? I don't know. But historically, this is the notation that is used widely by scientists and engineers. So if I use this notation in this problem, I could write that vy equals 13.1 j hat. And notice there is a positive and a negative direction. If this were going down, there would be a negative sign here, because j hat is always along the positive y-axis. So anyway, we will use this notation through the rest of this semester and into next semester. So it's good to know this IJK notation. All right, let's go to problem 2. All right, problem 2 should be easy. Do the sketch, solve it, and then come back and see what I did. Okay, there it is for you to look at. I drew the vector, I tried to get it so a little less than 45 degrees, I labeled everything, I used the equation for the x component, I put the numbers with the units, I did the calculation, it rounds to 198. This is, the distance is 4 significant figures, but the angle's only 3, so the answer has to be 3, and then I put it in IJK notation. Okay, easy. Okay, let's skip problem 3, since it's the same as the last one, only finding the y component, and let's go to problem 4, and we'll do that one, even though it's like problem 3. Okay, I think you've got the routine. So I drew the vector. I wrote down what the magnitude of the vector is. I put the units. Units are important. I forgot to mention that in the last couple ones. You have to put that into the answer in this case because the units aren't given. I labeled the x and y components. The reason I draw them as dotted lines is because there's one vector and two components. These are not separate vectors, they're components of this vector. So just not to confuse them with separate vectors, I draw them as dotted lines. And then I have the equation for the y component, f1y. Notice the notation is the magnitude of f1 times the sine of the angle. I write that down with the units. I get an answer with units, and I round to this. In this case, the I hat doesn't go in here. It's just you would put in 199g. And I should mention that grams is really a mass, not a force, but the weight of something and its mass are related. And we'll learn about that later when we study force next week. Okay, where should we go from here? Okay, before we proceed, let's talk about the force table, because we're not in lab and you don't get to use one. But there are a variety of styles. This is a good illustration of one. It has a stand. Oops. It has a base and a post, and it holds a force table with 4 pulleys that can be moved around, and a ring and strings attached, and a mass hanger, so you can put masses on here. So the 3 forces you're given, you put the pulleys, the first 3 pulleys, at the angles stated. You put the mass on the hanger, including the mass of the hanger, to get the right mass given. And you do that for the 3 forces that are given with the right mass and the right angle. And then you take the 4th string experimentally and you move it around until you find the position at which you can balance the ring. And then you put the amount of weight on there that will exactly balance F1, F2, and F3, so that when you pull the pin out, the ring won't move. That's what you do in lab. And that means that F1 plus F2 plus F3 plus F4 plus the sum equals 0. And so this actually, on the force table, is the negative of F1 plus F2 plus F3, because when added to F1 and F2 and F3, it equals 0. And so that sometimes confuses people. But that will come up in this in the assignment in the lab, and I may use this problem in the quiz. So that's the force table. It's good if you understand it. Okay, back to the assignment. Read problem 6 and try doing it, and then see if you get what I get. And make a table to list all the components and add them all together. I'm going to do it in a table format. You'll see what I mean. So try and do number 6 before you watch me. So here you have it. This is the way you should do it. I just did the x components, but the y components would be very similar for like the next question. So notice how I set up the table, x components, y components, and each x component for f1x, I take f1, and that's up here. I didn't write it out, so I would take 267.1 grams times the cosine of 22.5 degrees, and I get this number, and it's a positive number, and you got to pay attention to the sign. When I do that for f2, 186 times the cosine of 133 degrees, I get a negative number. That makes sense. It should be negative. I should draw this out for you, actually. And then f3, 126 grams, cosine 246. I get this number, and when I add them all together, I'm left with this. So I'm using this equation. To get the y components, I would use f1y equals f1 sine theta, and I would get those and add those. And then let me just tell you this now, since you're here. Then if I wanted to get the answer, which in later problems we'll want to do, this is what you would do. So you would finish filling out the table, and then you would get the sum of the y components, and then you would just use the Pythagorean theorem. You're taking the y component, the sum of the x's, and the sum of the y's, you're squaring them, and this gives you the magnitude of the answer, the length of the vector. To get the angle, you take the opposite over the adjacent, the sum of the y components from here, divided by the sum of the x components from here, and take the inverse tan, and that will give you the angle. The only thing here is you do have to be cautious. You got to look at the diagram and the angle. This could be the answer, or you might, in some cases, have to add or subtract 180 degrees. So if you look on the equation sheet, you'll see these equations and the other two that using any vector A or F, any vector, ax equals a sine theta, ax equals a cosine theta, or fx equals f cosine theta, fy equals f sine theta. You'll see those equations. Those are the equations you use, and that's how you solve vector problems. Let me draw the figure. That's also important. Okay, once again, I can't stress the importance of drawing the figures and conceptualizing, visualizing these problems. So notice I picked an angle. It might be a little too big, but I just estimated 22.5 degrees, and I just drew a line. Now, if this is 267, 186 has to be a little shorter. So, I don't know, maybe I made that too long. And I have to estimate 133 degrees. So that's my estimate of 133 degrees. And this looks like it's a little bit shorter. Maybe it's too long. But anyway, it's an estimate. And then 126 at 246 degrees, well, that's 270. So this is my guess for 246 degrees. And this vector should be less than half the length of this, so maybe that's still too long, I don't know, but I drew it. And then this is my answer. So here's the start, 1, 2, 3, here's the end, here's the start, here's the end of the single vector. So this red vector is the same as the sum of these three vectors. And notice that it has an x component. Let me just use this. It has an x component, right? Imagine the components. It has an x component and a y component. And you can see from my figure that the x component is relatively small, but positive. We didn't do the y component, so I don't know. But the y component is also positive and longer. And you can see that this angle is what? 65, 70 degrees. So when I go through all this and do these calculations that I mentioned, I have some idea of whether or not I'm getting the right answer because I've drawn the figure. So once again, the importance of learning how to do diagrams and visualize these vector problems. So now we want to, 7 is the y components of a different set of vectors. And then 8, person walks due south. Let's read number 8. So 8 is pretty straightforward. Let's draw, we go due east a certain direction, 216. And then we go due south, almost the same length, but a little bit shorter, so like that. And how far are they located from their start position? So here's the start position. Here's the end position. The sum of these two vectors would be this. And so if this is 216 and this is 202, I'm going to guess this is 300, right? But you see, since they're x and y components, you're just going to use that equation that the magnitude of the resultant vector is the square root of the x component plus the y component. So those are like components squared, right? So that's how you would get that. And if you were going to get the angle theta, you would use that inverse tan function. And this would be negative. This would be positive, and you would get a negative angle. You would get the correct angle, and it would be a negative angle, right? If you go this way, say this is 42 degrees, this would be a negative 42 degrees. And I think the next problem discusses that. And again, don't forget to put the units in your answer. For these type of problems, it requires units. Okay, number 10, last problem except for the mops. So read it over and think about it. And go as far as you can before you watch what I do. So before we do the problem, here's the river, and then let's say you point the boat straight across. You can row at, according to this, 354 meters per second, and the river velocity is what, about a third of that. So the river velocity is going east. Did I get this right? The river flows east to west, from west to east, right? And so you want to go to the north bank. So that's it. So what's going to happen is you're going to get in the water, you point the boat straight across, and you're going to go in this direction. And this is your rowing speed. That would be your speed if the water weren't moving, but it's moving, and so you're going to go in this direction at this speed, and you're going to end up here. And what would this be? Well, that's just, your resultant velocity would be the square of your rowing velocity plus the square of the river's velocity. That would give you your resulting velocity, and the direction you would go in, right, would be the inverse tan of the river velocity, the y, over the rowing velocity, the x, right? Now, if you don't want to end up downstream, obviously you have to point upstream. But at what angle? It turns out it's not this angle. Okay, so when we think about how you're going to point upstream, the key to thinking about it is you want to go straight across. So you have to go upstream such that your x component of your rowing velocity going upstream is exactly equal to the river velocity. And so the resulting velocity will have no no x component, excuse me. It'll be all y component, and you'll go straight across. You can also think of that in table format. I'll show you that in a minute. So here's what I just said looks like in the table format. So we have the x and y components of VP, that's V person. VR is V river, and VB is V boat. What's going to happen to the boat? And so V, the x component of the person will be V person cosine of the angle that we don't know. That's the angle we're looking for. The velocity of the river, the x component is the 114. And when we add these, they have to equal 0, right? Because the boat, to go straight across, must have an x component of 0. And then in the y column, we don't necessarily need that. The boat velocity times the sine of this unknown angle plus the y component of the river velocity is 0. That will be the final velocity of the boat as it goes across the river. So this is going to be equal to that, because if we add these up, we get this result. So it's from this column that we get the equation that we need to find the unknown angle that we need to point the boat in. So let's write that equation out. So here it is. This plus this has to equal 0, right? You sum these up and you get this. And this is 0. Why? Because we want the boat to go straight across. So V person cosine theta plus 114 meters per second equals 0. Cosine theta equals negative 1.14 meters per second over the V person, 3.54 meters per second. The meters per second cancel. Theta is the inverse cosine of that negative number, and I get an angle of 108.786 degrees. I rounded to 109, but be careful. Easy to make this mistake. It says, in what direction measured from north must the person point the boat? So measured from north, we have to subtract 90 degrees from this, and so it's going to be, when we subtract 90 from this, what do we end up getting? You do want to subtract the 90 from that, because you're going to round and you're going to get 18.9 degrees. That's what I got. 18.9 degrees to 3 significant figures. So that's to the west of north, right? Okay. Okay, so the very last thing is, whoops, I don't want to erase that, the mops, right? So these mops are good. Do these. In fact, you should do these maybe before you do the assignment. And do them carefully, and it'll give you good background about vectors and scalars and all the basic concepts you need to know, and you'll be in good shape for quiz 3.